And the Ping rocket has launched. We are live with Dr. Erik Henrikson from Ping, the Director of Golf Science. Erik, it's good to have you on.
Yeah, excited to be on the show.
I had Dr. Paul on. It's got to be 2 years ago, and it's hard to believe it's been that long, but that was a lot of fun with him, and I don't know why it's taken me so long to ask you to come on, but we're here, so that's the important thing.
2 years is a good spacing between us. We overlap a lot in what we tackle and work on, and have some unique paths too. But he hired me, 13 years ago, so we've been working really closely on a lot of projects we work on here at Ping.
As I follow, because I after I got done playing, when I took my shot at fame and glory, and it didn't work out, and then got through putting a body back together after the beating you take from playing so much and sleeping in different hotels and you're driving and the whole thing. But I had worked for some very, very smart guys who were engineers and fitters, design shafts, design clubs, consulted with companies and so on. And they had told, and this would have been about 2007, I started working with them. Mm-hmm. So right before you guys really, I think Paul was already there, and you were about starting there, and right around that time.
Yeah.
But shortly afterwards, as I worked with them for a couple of years, they were saying, that they had, as they took clubs apart and put things back together and measured and did their thing, there were certain companies that had certain characteristics on their clubs that they could identify. But shortly after I was working with them for a couple of years, they were raving about Ping, like all the design process, one guy called it the arc center line weighted distribution. So where the distribution was on the club head based off the center line that the club moved on its path. Mm-hmm. And then as I got to know you guys through meeting at Coach Camp and always enjoy your presentations and follow you guys online, I kind of put two and two together and said, wait a minute, I know these guys are really smart, but as I look at when the guys who I knew and trusted very well said Ping is doing some really good stuff, and I looked at when you guys started, it coincides. So it's no secret that, given who they have working for them, you, Paul, and Marty Jertson, who I'll have on, and Chris Brody is with you guys now. Yeah. I'm sure you have a whole team of people who are very, very good, but it just coincides with this great products year after year. And, we're going to talk about a lot of that design and innovation today.
Yeah. I mean, it's, when I started at Ping, I was coming out of grad school, finishing up my PhD, interview with Paul, and then a director of innovation at the time. And they were kind of starting up this innovation group. When I interviewed, one of the things that really stuck with me and kind of, led me to be pretty excited about taking the role was that, they're like, Ping is not a golf company. We're an engineering company, and we make golf clubs. Mm-hmm. I grew up in Phoenix. My grandfather was a Norwegian engineer, worked for Hughes Aircraft, knew Karsten, and was a big fan of Karsten. And obviously Karsten being an engineer and having a fundamental understanding of mass properties. And, he'd say he's in the business of moving mass around. Right. Mm-hmm. And he understood those fundamental principles better than anybody at the time. And so I was pretty excited to come in and having a research background, in the engineering field and kind of being a scientist and an engineer, really tackling, continuing to gain a better understanding of the fundamentals that govern golf club performance, that govern what produces ball speed, where energy is lost, what generates spin. And I think that's been a foundation for, us. It's been in the DNA of Ping since Karsten started, because that's what he based all of his, you look at some of his initial videos, it was all fundamentals of how things work. And it was really fun to come in, and I'm glad Paul hired me, and I get to do that every day. And so, it's based a lot on just kind of fundamental research and understanding the why.
And all the engineers and physics guys that I had learned from, that they always spoke very highly of Karsten. In fact, mm-hmm. I had heard from a number of, and these guys did not know each other, but I heard this story numerous times, and it could be skewed over the decades. But when he designed I think it was the first answer putter, and he had taken it to one of the PGA events there in Ohio before I think everything had moved out to Phoenix or Arizona, and he was giving it to some of the guys to try. Trevino was there, and Jack Nicklaus was there, and and everyone was saying, "Hey, man, this thing's really, really good. This is awesome." And Jack Nicklaus said, "Well, I think if you move some weight here and some weight here," and Carsten snatched it from him and said, "If the weight was supposed to be there, it would have been there already." So yeah. I don't know how true that is, but
well, I've heard it similar. So I play out at Moon Valley Country Club, which Ping used to own, and Carsten lived on the number 10, like right by the number 10 tee. House there. Andy now lives there, one of his grandsons, and he'd go hang out on the putting green. There's a little practice putting green there. And this is later, it was probably late 90s or, mid 90s. And somebody was with a ping putter and they had a bunch of lead tape on the bottom. And he goes over to him and he goes, "Who do you think knows more about putter design, me or you?" That putter's just fine without any of that lead tape. That's the story I was told. So he, that sounds very much Carsten in terms of if it should have been there, I would have put the weight there.
As being an innovator, and you take the answer design, which now has been replicated more or less by, and every company out there makes it, and he was the first. And then you have the cavity back irons were back in that era, everything was forged. So the innovative and creative mindset, even though it was an engineering background, it blended both, as we talked before we came out. Very similar to Apple, in my opinion, in that they took a very scientific engineering product but how do you create beauty with it? Which is, you guys have done that in the golf sector phenomenally well. How do you we'll just jump into just kind of talking about the process of what you're director of golf science, so you're the innovator that comes up with these things. I'm sure you guys have a round table and talk about what you want to do, but can you just talk about how that process goes, and then we'll just roll from there?
Yeah, I think if you look at, you mentioned Apple, and I think you have Apple, incredibly innovative company. They have made products that have changed human behavior, and then another one I look at a lot is Bell Labs. So Bell Labs, part of Ma Bell. This is, maybe a little older than kind of the Apple story, but, they invented the transistor, they invented the solar cell, they invented lasers, like these fundamental technologies that Apple wouldn't have been possible without what Bell Labs did. And Bell Labs, they invested a ton of money in basic research. They had this big, basic research, a lot of scientists that were looking at solid state chemistry and semiconductors and all these things. And, and they realized that, the inventors and the inventions are the things that just captivate the public, right? Those are the things that people look at and go, but the important thing is the knowledge that makes those innovations and those inventions possible. It's the physics understanding, or in Apple's case, I'd argue their big innovation was understanding people and behavior and what would make people's lives better and how they would use product. I would say Bell Labs was much more the fundamental technical sciences and the physical sciences and understanding that allowed them to, invent the solar cell and the transistor. But both those stories are at the bottom, like innovation that lasts. I'd like to think that the innovation that Ping introduces to the industry is innovation that lasts, right? It's not, innovation that you see for a product line and then it goes away. And innovation that lasts is based on good fundamental research and a good understanding of what the trade-offs are. And so we spend a lot of time answering why questions, why things work, why do we see something? There's a lot of players around. There's a lot of people who don't play golf and see things from a different perspective, but we are a curious people, right? I think we have this culture of curiosity, and our best innovations come from a curious mindset where we'll run experiments to just kind of see what happens and try and understand why something happened better. Because if we can understand the why, then we can start to make things that contribute a significant difference to performance. And so, one of my first experiences with this was, I remember it was really early on, and people have probably heard me share the story before if they've heard me talk, but I was in this meeting. It was like my first 2 months, and it was a golf science meeting. So it was one of these meetings where we're, bringing up test results and research that we've done to discuss and say, okay, have we answered that question, or do we need to do some more testing? And John Kay, so our current CEO, one of Carson's grandsons, had gone out and played with a couple engineers over the weekend, and they had this experience where the fore-iron was just ballooning up and landing short. And it was early morning, there was dewy, and it was like, why in the world is that seeming like it's spinning more and falling short? It's wet. Shouldn't it slide up the face and lower my spin rate and go farther? Like, what is going on? And he kind of turns around, and Paul and I are kind of against the wall in the conference room. He's like, you guys got PhDs. Why does that happen? And we're like, I don't know. But it sent us down a path of doing some research to answer that question. Why does that behavior happen on a fore-iron? And so you go and you read some papers, and you create some mathematical models that can kind of emulate that behavior. And if you have a physical model that emulates the behavior, you now kind of have a tool to kind of explain why something happens. And we realized that like this, behavior of spin increasing or decreasing when something gets wet is actually a function of loft. So you do that on a wedge and you are going to lose spin, but you do it on a driver or a fore-iron or something with lower loft, you actually get more spin. And it has to do with, kind of the way the ball interacts with the face and this thing called like the compliant nature of the rubber golf ball. And so it led us to roughen up our driver faces to try and create more friction actually, and lower spin rate. So if you notice on all of our drivers, they have this brushed surface.
Yeah.
And so that's an innovation, right? We took a product and we integrated this feature that made a significant difference to performance without having to change our center of gravity. Right, we broke a trade-off. Typically, if you wanted to lower spin, you'd have to move the CG down and forward, which you'd sacrifice MOI, and it's like this trade-off that a designer goes, man, I don't want to work along that trade-off. I want my cake and I want to eat it too, right? I want more MOI and I want my CG here, and so by being able to just treat the face with a rougher surface, we were able to lower spin rate without having to sacrifice in any other areas. So, to me, that's a good example of how we view the innovation process of spending a lot of time trying to understand the problem, spending time exploring questions of curiosity, and those insights that we gain end up leading to innovations that we have confidence change performance, and will change performance like forever, right? We understand the trade-off. And so every once in a while that, a rougher face or like turbulators, they're no longer on a fairway wood. The reality is they didn't improve aerodynamics a great deal on a fairway wood, just based on the geometry. It's already a small club head. But when we started to incorporate our face wrap, so this miraging steel face wrap to get more ball speed over a fairway wood, we're like, okay, we'll take that more ball speed over maybe a fraction, of a mile an hour gain we get with the turbulators, if that, to make that, to put on our face wrap. But that's the fun I get to have, is doing that basic research. And you've seen even in the coaching community, it can help out the coaching community as well, because they have these questions. And we learn a lot from interacting with the coaching community, because we're like, man, I see this out there and I don't understand why it happens. Sometimes we have an answer, but a lot of times we don't. And then when we come in and we do some of the research and find an answer, I mean, it benefits the coach because now they know what's going on and why, and how to guide a player maybe in a different direction. But for us, we then go, man, we might be able to leverage that to solve our problem with equipment, and so, we start with the basic kind of research. We then find embodiments that leverage those insights. And then once we have, find a technology that leverages that insight, we then work with our design team to then incorporate that technology. And that could be a new material. That could be just a novel face geometry. So, our fairway wood, starting with 425 and with the 430 product, our drivers, we've done a lot of optimization of face curvature and center of gravity location and MOI using some of the models we've developed, our predictive models. And we drive those with our motion capture system, and we could get into that later. But we then can tune that face curvature, right? And the designer's like, this is great. I can level out spin rates up and down the face without having to, tweak some of these other variables that I otherwise would have to, I get effective MOI without having to spend the effort to, the trade-offs to increase my MOI by implementing this face curvature. And so, I hope those are some examples that help paint a picture of how we go about innovation. But it's really, again, it's starting with the curiosity and the basic research, taking an insight, leveraging that insight, creating something that, uses that insight, and then working with the design team and our project engineers to figure out how to get it into the product, and a lot of times how to make it, right? Working with a supplier to figure out how do we implement that new material or that new geometry.
It kind of reminds me of what Doc Brett McCabe told me when he was on. I asked him about, can you ever reach your potential? And he said no. And then he went on to explain why, that every time you improve and get better, your potential is actually changes. So it's constantly evolving. And I think that it was either he or I brought up the example of Castaway with Tom Hanks when he loses Wilson, the volleyball. He's out at ocean. Every time he swims towards the ball, he's pushing it further away. So it was very similar to that. And it seems like, with all the innovation and the rapid advancement of it in today's world, that it's got to be very enjoyable sometimes and probably very frustrating for guys like you and the team. And that it's almost hard to, because it's all new. It's like, okay, if we integrate this, we're not sure what it's going to do, so let's go test it. But I would have to assume that the testing part would almost be one of the most enjoyable things. It's like, okay, here's what we know, or at least what the science has told us up to this point with the ability to measure what we have. Let's go try this and see what happens. Kind of like going on a bit of a treasure hunt.
Mm-hmm. No, 100%. And I think, sometimes you have a hypothesis and you test it and you're like, wow, that held. We now understand how this happens. And you go up and say, let's incorporate that. And a lot of times it doesn't. And, over time, if it doesn't happen, you're kind of like, man, this is a little frustrating, but that's an opportunity, right? And every kind of, every time you hit that adversity and that challenge, right, it's still a path to success. I don't know if Giannis, right, the all-star from the Bucks, right? They're out of the playoffs. He was all over the internet this morning from his press conference because he got the question of was the season a failure? I thought his answer was tremendous. He's like, "Why are you asking me if this is a failure? Do you get a promotion every year? Is your last couple of years a failure because you didn't get promoted this year again?" It's like, no, this is a path to long-term success, and we're going to come back next year. And I thought that was a tremendous mindset, and I think that for us, every time that we don't understand something, we could get frustrated. But I mean, tell the team, I'm like, this is an opportunity to learn something, right? Mm-hmm. We don't understand. That means there's more, right? There's more to learn, and there's more areas to explore and push the envelope.
As a scientist, and your education is in that, your family has had a history in it, and you obviously work in that field. Does it get frustrating? Or maybe it wouldn't be frustrating, but you're dealing with a lot of laws of physics and working with Doc Sasho and biomechanics and things like that. But when you're working to see testing things, how do you navigate between what is known as laws and then what might be changing, or the results that you're getting, maybe not necessarily the laws, but maybe common held beliefs are now going to be challenged. And even yourself, you say, wait a minute, we're seeing this over and over, but how can that be? Mm-hmm. How do you navigate that dynamic?
Yeah. And I mean, there's navigating it with the consumer and coaches. And then there's a lot of times navigating it internally. I think, we've had conversations with, John A's been designing golf clubs a very long time, and he's forgotten more than I know about club design and how golf clubs work. And, there's a ton of times where, Paul or I or some of the team come, insight, and he's like, well, let me take you over into this old building where we have this machine where we did that in, 1972. And you're like, oh, well, nothing new under the sun. But there are some times where we uncover an area that it might not be, it might challenge kind of a belief that somebody's had here who's been here a lot longer, and may have worked with Karsten, and I believe Karsten had, but ultimately kind of data wins. And I think the difference between now and Karsten's day is the technology that we have at our fingertips to be able to gain a better understanding of what's happening. And I think that's, Karsten would, he would be fascinated with the ways in which we're able to measure what's happening compared to, when he was designing clubs, his ability to measure things. And so I think that's where, when you test and you get a surprising result, the first thing you want to do is we're going to run another test. Sometimes we'll go, hey, Sasha, you want to run this test up in your lab? Make sure you get the same result because it's surprising to us. And let's make sure there's no bias in our, you set up your method and run it with your player pool, and make sure we see the same thing. But the ability to, you mentioned, 2007, 2008, that was an exciting time, right? Launch monitors, all of a sudden were like starting to become, really accessible. There was no such thing as a low spin driver,
No, I suffered from
until
that.
2014 or whatever, when all of a sudden we started on, guys, Nick Price was like, I want to see this low bullet that kind of rises, and it was like all by eye. And then you start getting on a launch monitor and you're like, wow, there's some opportunity here, right? And everybody, they didn't know it, right? Everybody wanted to hit a big draw, right? And what they're doing is they're de-lofting the club and lowering the spin rate, hitting that draw, and getting more distance, right? Now everybody's hitting a cut, right? They have drivers that aren't spinning enough, and so they're hitting a cut and at least a little more stable ball flight. But that's a different discussion. But launch monitors, motion capture, MEMS, you now got AI-driven motion capture that is advancing, and with all these tools, we're able to kind of it talked about questions and curiosity, and we now have these tools to answer these questions, and we could rerun those tests, and ultimately for us internally, and and that's working with our sales team. It's like, hey, here's the data, here's the results. We've tested this, and here's the performance gain, and ultimately that's what wins. And sometimes it's expanding on a belief that's held. It's sometimes revealing, oh, I always knew that happened, but never knew why. And sometimes it's like, well, we had correlation, but that wasn't the cause, right? And, correlation doesn't equal causation. It's like, well, there's this other thing that was actually happening, right? It's when you hit a wedge low in the face, it spins more. It's not the CG. It's just that you had cleaner contact. It's not that all the CG on wedges should be really high because it generates more spin. It might give you lower ball flight, but it's not going to influence the spin a whole lot.
How do you individually, and then obviously the team that you work with, because it's very difficult, at least as I've found, I got in the podcast world and I had no clue what I was doing. I really still don't. I just really enjoy talking to people. And that's why I have such a wide array of guests on the show. I have a big curiosity about a lot of different things. But one thing that I found was it's sometimes as you get into the technical side of doing anything. So for me, it was, learning how to put a podcast together, or if it's just life in general, you're focused on one thing that might be more mechanically driven. That's the phrase I'll use. But then sometimes it's very hard to shift gears to get into the creative side of it. It's like I almost have to take a couple of days away from everything to let everything in my own brain level out, and then I can get somewhat of a creative mindset for a few days to say, okay, if I want to tweak the podcast or the show or whatever this way, this is what I'm going to do. How do you do that as someone who's a engineer by nature? You're going to, I would assume you're going to be prone to being more structured, but you also have to integrate that creativity, because that's, again, as we discussed, that's what the company's founded
on. I think this may sound simple, and it'll kind of answer for the team and for myself, is like, to start, we schedule it. We say, hey, look, this is the time to kind of talk about things, look at things together, and be creative. And so we have a meeting every 2 weeks, which is it's a golf science meeting. And it has members from my team, the golf science team, members from the design team, project engineers, Chris Brody's in there, Marty's in there. It's a big meeting, and half of the attendees are virtual. And the whole meeting is answering curious why questions. And when we get to the answer to those questions, they always spark the creativity of like, oh, that's how that works. What if we, went about it like this or looked at things this way? And so by we have I'd say everybody on our team, regardless of what team they're on, everybody in engineering at Ping is a scientist. And like our goal in the Gulf Science team, although we're a component of engineering, is to make everybody smarter around us. And we have some incredibly bright, like our design team, like Ryan Stokey, who's our director of product development, Corey Bacon, incredible amateur golfer, as well as Travis Millman, both designers. Corey designed the G430 driver, Travis the fairway wood, Evan Greer designed the irons. You obviously mentioned Chris Brody, really bright guy in terms of just data analysis and understanding golf physics. A number of members of my team were all in this meeting. And if we can make everybody smarter by revealing these things, everybody goes away from that meeting going, oh, well, what about this? And they'll come in the next day and go, hey, you were talking about this funny thing that happened. And, it seems like this was why. What if we did this on this club? Because that can leverage that. And so I think, that's encouraging that creativity and encouraging the curiosity. And I think curiosity is a key ingredient to creativity, right? You have to be curious and always wondering why to be creative. Because if you're not, like, you're never going to go down that road. And so I think that's one way as a team, we make sure like every 2 weeks we're getting together and as a bigger engineering group and talking about data and results, but then that leads into great discussions on how things work, why they work. And then that leads into creative discussions of like, well, let's brainstorm. And that just, it tends to happen organically. And we're fortunate. We got a driver engine back, we got motion capture system, we got a swing robot. So half the time you come out of that meeting, somebody goes and grabs something and, take down the shop, weld it backwards, and then go hit it. And go, what happened? You've probably seen Andrew came in and did a little article on mud ball research, right? And it was just one day it was like, a couple guys played an event over the weekend, got an argument in the 2-man event, which way the ball was going to curve with mud. And we're like, well, let's go test it, right? We got plastic out in Pingman and got Ping's finest mud and go test it. And we're like, okay, this is what's happening. I know it's not leading to club design, but it's kind of an example of just the holes will go down. And
if you get science-minded people that are very interested in finding out and continuing to learn and see what happens, and then you bring them together, and all of them are playing around with whatever they're focused on at the time. And okay, let's see if I do this. Let's see what happens. And as Doc McCabe said, that never ends because you're always getting new results. So your brain is always thinking, okay, what if I tweak this? Or especially if you've been in it long enough, you can use the laws and the science that and say, okay, here's what I know, but here's what I'm seeing. If I adjust this a little bit, what's going to happen? And then you bring a group of people like that together, and it can really be tenfold or 100-fold of what that can evolve into.
Yeah, it's a ton of fun. And we got, not everybody's a guy on my team. He's one of our, simulation experts. He's been at the company 23 years. And he's may have owned every Lego set that's ever been made. Doesn't play golf, but big time gamer, big time Lego fan. And he will come up with ideas on how to implement things that you're just like, whoa, where did that come from? And you get enough perspectives and enough, everybody's kind of got, all of a sudden you get this kind of cross-pollination of ideas centered on curiosity and physics. And it's exciting. I think there's this book I read a long time on innovation, and they referenced, Apollo 13, where crud, we're in trouble up here, and all the engineers down at Johnson Space Center were pouring every part they could think of that would be, on the spacecraft, and they dumped it all on the table to try and figure out how to get the air filter to work, or what, I don't remember what it was that was going wrong, and they couldn't figure it out, and then they just got more parts on the table. A lot of times innovation is just getting more parts on the table. All of a sudden you start to piece some things together and you're like, wow, all of a sudden we have something special that's addressing the problem or the question we're asking.
It reminds me a lot, Ed Catmull, who was the CEO and the founder of, what the hell's the name? Pixar. Mm-hmm. The book that he wrote, Creativity Inc., was the entire history of Pixar and how they started it. Of course, they're all computer scientists. So they're all kind of engineer-minded, scientific-minded, but they're obviously the company was very creative. And then it goes through their development. And then when Steve Jobs came in and bought them and said, look, you guys do this. But then when they combined with Disney, at the time, Disney had really plummeted on their creativity and their ability to produce things that were really interesting. But one thing they did when they went in there, they removed all of the walls in between offices. They might have had some partitions, but it was more of an open type meeting space or environment where people could get together. And you guys, with your every other week doing something like that, I mean, you got to have that to foster the creative thing, or else it's just going to sit there stagnant in somebody's mind, and they're just, no one's going to use this.
Yeah. And that was the biggest challenge over the last, I'd say, probably since you talked to Paul. I don't remember if it was pre-COVID or not, but I think one of the biggest challenges for us over the last couple of years has been with, a bit of the blip and, figuring out, everybody being at home for a little bit and trying, how do you foster that level of, and that dynamic virtually? And we've found some good rhythms, I think. But that was definitely a challenge kind of, in that blip called COVID, trying to maintain that level of creativity and innovation and, just that dialogue, a team coming together. There's no substitute for being in person. I think it's really hard to do virtually. Right. There's ways to do it, but yeah.
Now that kind of lays the groundwork for the understanding of the process you guys use. So if we took that and applied it to some very successful products that you guys have had, either the G430 line or the glide wedges, which you touched on, the ability to create spin with water on the face. Can you go into a little bit that how using that process and then we tie in the product, how that came about, how it evolved, and then how it came out to the consumer?
Yeah. So
the story, I guess, of the product, the story of either of those products, whichever one. Yeah.
Well, the G430 driver, I think, is a really fun one because there's a number of elements, with that driver that lead to the performance that people are seeing in the fitting environment and on the course. And I think when we set out to design that product, we were looking, always want to increase ball speed. We knew that we had done enough research on kind of face curvature and particularly, roll curvature, where we wanted to eliminate that low shot that kind of ballooned up on players and create a more consistent spin rate performance when people miss high and low on the face. And then we wanted to work on sound. Those were kind of the three big things that we wanted to work on. And with the G430 driver, if you look at it, you're going to notice, one, the face is a little shorter than previous generations.
Shorter meaning sole to crown?
Sole to crown. Yeah.
Okay.
So face height. And I think at a glance, you're like, well, why would you would think making it bigger, big old trampoline would give you more ball speed. But as we ran simulations and we could get into AI and all that, but we ended up exploring the trade-off between face height and face thickness. And, how do you extract more ball speed and maintain conformance, right? Everybody always asks about USGA regulations and all that stuff. And so we were exploring this space of face height and face thickness. And we found, as we were varying those two variables, there was a face height and a face thickness that allowed us to extract more ball speed and maintain conformance. And really that face thickness, it's the thinnest face we've ever incorporated in a driver. So we found that actually going with a shorter face height and a thinner face gave us that we were getting 1 mile an hour more ball speed out of it than 425, which was really exciting.
And it didn't sacrifice face integrity.
So when we run these simulations, right? We're looking at durability to make sure that, over the lifetime of this product, we're not gonna have issues with them breaking.
Mm-hmm.
Don't want to break on tour for sure, and breaking, and swing speeds have continued to increase. So constantly evaluating our durability standards. And then we wanted to ensure that, like, okay, so we might increase center ball speed, but are we sacrificing non-center ball speed? Right. So we run those simulations off center, and then obviously do a lot of player testing when we have physical parts. And then some of that stuff can affect things like sound. They can have unforeseen effects on other elements. And so we were able to do a lot of that via simulation and develop a good knowledge base to then allow Corey Bacon, our lead driver designer, to go, okay, here's the face thickness and the face height I'm going to go with. We also had a bunch of optimizations that we ran in terms of face curvature based on the CG location. So we have a physics model that can predict what the ball flight's going to be and what the performance is going to be. If we vary, there's all these knobs that a designer can turn and a scientist can turn with club design: MOI, CG location, overall weight, the geometry of the face height, like tons of knobs. How do we turn all these in the right combination to get us the most performance? And so he then took the optimal kind of roll curvature and it varies. So we have 3 different models. We have our max model, which is the most forgiving. We have our LST model, a lower spinning head. And then we have our SFT that's meant to kind of fight the miss to the right for, the right-handed golfer. And each of those has a unique face profile based on, the CG location and the
Mm-hmm.
player that it's designed for. And so it's really fun to, innovation's always fun when you can point to it and go, look, turbulator, or look, I can feel the roughness on the face, or the new blast on the wedge. But a lot of times the stuff that's leading to those performance gains is these small details that, yield performance, but are just based in a really good fundamental understanding of the physics involved and optimizing the different variables. And so, talk a lot about simulation. We also did a lot of simulation on sound, trying to understand how this new design that Corey developed was going to vibrate, and what acoustic that was going to, lead to when a player hit it. And so I think we really optimized things very well for that G430 line. And then on the LST, we implemented carbon fiber, and on all of our favorite fairway woods as well. Saved us about 10 grams on the fairway woods, 4 grams on the driver. First time we've implemented carbon fiber in a while since Rapture. But that was also something we had constantly been evaluating and go, okay, when's the time right to, we're not going to implement it just to have it, right? It better save us some weight or provide a performance benefit. So, each of those elements, the face height, face thickness trade-off is kind of like, I'd say, one project innovation, golf science understanding that was implemented. The roll profile was another project that was implemented. The acoustic research was another piece that was implemented. And then kind of the carbon fly wrap on that LST was another piece that was implemented. So, all those different pieces kind of come together to, and provide those incremental gains to lead to a performance benefit that people see on tour and in the fitting environment on the course.
How long did that whole process, how long does something like that take from start till when products launch to the public?
Yeah. So, we're working right now on the G430 replacement. We've been working on that for, maybe 6 months. So, it's, 24 months is when we really, 18 to 24 months is when we really start kind of going, okay, what do we want this to do? And it's sometimes it's tough, right? You're already designing the next one, like before the last one you designed is on the market. So, it's where a lot of our internal testing is super important. But you're always, that last kind of test is what's happening out in the field, what's happening with the tour players to kind of help us guide us on what we need to address with the next design. But I'd say, like, the primary incorporation of the different insights 18 to 24 months. Some of the research projects that lead to those insights, a couple years to develop and work on even before we hit kind of that primary design phase. And the models we use to do the optimizations were models that have been years in development and working. So like an impact model that, you could go in and any of our designers could go in and go, okay, here's the MOI, here's the CG, here's the face curvature, here's the face material and thickness. And, here's the player from our motion capture database that I want to optimize this for, see the performance of. That model's taken, and it's continuing to be improved, right? I think, you've probably heard all models are wrong, but some are useful. And so they allow us, they're not perfect, but they definitely give us insights into what's going to happen and where we have some room to improve.
Are there times where models where you think, let's say X amount of years ago, that it didn't bear the fruit at that time that you had hoped it would, but you kind of put that in a file, and then maybe you're working on something now and you say, hey, wait a second, remember when we did this with this product, and hey, let's go back, and I think that might help with what we're working on now. And then, what looked like a dead end for any amount of reasons, that maybe technology on something else didn't allow that to perform the way it was supposed to. And now you have that. And now all of a sudden that just kickstarts everything again and sends you down the direction you wanted to.
Oh, 100%. It happens a lot. I mean, you talk about AI, just the computing power we have at the moment is way more than we had when I started. And so our ability to quickly generate insights, allows us to innovate quicker. It allows us to get these answers to our questions a lot quicker, and improves, a lot of times even improves our accuracy. Because we can, maybe incorporate more details in the design that we weren't able to before, because we have now the computing power to run those models, run those simulations, and get more accurate results. And so, it's kind of how things go, right? As time passes, capabilities improve and technologies become available that allow you to, make advancements where maybe it was a dead end, a number of years prior.
So AI is a very big topic across the world. Anything you look at, AI is influencing car development and oil drilling, and you fill in the blank of whatever industry. And obviously it's made an impact in golf. And as we're talking about the design process of a golf club, or whether it's a driver or wedge or set of irons or putter, and that process takes roughly 18 to 24 months. How is AI influencing what you guys do? So does the design team come up with something and ideas and then take it to the AI, or is it you might have an idea and you go to AI first and then say, here's what our idea is, and they give you some info and then you take it to the club designer?
Yeah, so I mean, I think AI is a very broad term, and it could cover anything from kind of rule-based algorithmic decision making to like a neural network. You've heard that term, where you train this thing up and you show it pictures of a cat and a dog, and you show it enough pictures of a cat and a dog, and eventually it can go, that's a cat, that's a dog. And so, I think we've been using flavors of AI, or what you might be able to call AI, for quite a long time. I mean, there's just certain, things like machine learning. Its foundation is statistics, and we've had, these big databases of motion capture data, player test data, and so we've used, clustering algorithms and things like that to go in. So it's kind of in terms of machine learning, which kind of sits under the umbrella of AI. It's kind of unsupervised and supervised. Supervised is kind of training something. So you have like a labeled data set, which is great for fitting, right? So if I have like 100 players and I label, hey, these guys did best with this and these guys did best with this, and then I set a, machine learning and go, okay, identify, what elements of those players and those players are unique, then I could go predict that later on, right? I can use that model to then go and say, okay, like, here's the model. Now I have Pete come in and I'll be able to put him in one of those categories. It's miles different from the cat and the dog analogy, right? And so we've used it to help with fitting. We had a device, and it's probably one of my favorite projects to work on, and one I thought the most proud of, but it failed in the marketplace, sadly. A little fitting MEMS device called in-flight motion, and we had developed a model that used this MEMS data. You know, MEMS devices were all over the place for a couple of years, right? You went to the PGA show, and there's like 10 different devices floating around, and you know, over time you kind of realize, well, it's cool technology, but like, is there a use case that's providing value? But for us, we found a use case that provided value, and it was just a really slick fitting where we could do a driver shaft fitting in 3 swings. And a lot of that was kind of going in and having a database of players knowing what shaft they were fit into, and then, you know, creating a model that then could use that labeled data set and then now predict in the future. But it was kind of takes the fun out of a demo, because if you're going like, well, that's my shaft and it works really well, it's like, but part of the fun of the demo is hitting new things. So that's a bummer. And then I think I learned a lot about product and just in the fitting environment of, you know, what are the behaviors in the fitting environment? What does it take to change behavior? You know, you have devices that need to be plugged in and all that stuff. And there's a lot I learned from that, but that's an example of where we used, I mean, that's 2014, 2013, where we used what I can, you know, categorize as AI. More recently, a lot of it comes down to, you know, I mentioned optimizations, you know, trying to find what's optimal. And so, and I know you had Ishmael from Altair.
Yeah.
So we use Altair tools. So it's finite element analysis tools that help us understand stresses and predict performance and durability. And so we can use those tools to run through a lot of different iterations very efficiently and try and understand which one's going to provide the best performance. And so whether that's using some of our physics-based models and running optimizations there, or using our FEA models and some of the tools that Altair produces to say, hey, is there a more optimal face geometry, or a more, you know, a way I can save weight here without, you know, compromising the structural integrity of the head. And these tools have gotten really good at doing some of that. Now, they're only as good as the kind of constraints you give them. You know, kind of garbage in, you get garbage out. But
yeah, that was a question I had for Ishmael. I said, how do you, I know that from the days of club fitting, that if somebody's clubs were significantly off from where they optimally should have been, let's say that either the profile or the flex, let's say the flex was 35 cycles too stiff. So the data input was so skewed, what it gave out, it was going to be much better, but was it going to be optimal for that person? So my question to him was, how do you account for the data that you're putting in and how much it could be off, because it's going to, the AI, and you know, as it learns, it's going to continually give you some data output. So how do you work or account for that? And he said, well, there's so much data getting put in now that there is a plus minus factor on what is siphoned off the top and the bottom to come up with a median, or more an average than a median.
Yeah, I've heard AI, you know, people call it AI, like it's like a chimp army. You know, they can do a lot of things really well if trained correctly, and if given the right constraints. And so, you know, I think that's what makes me feel good about having some longevity of my job. But, you know, being able to kind of, we're just saying, like an objective function. So that's the measure of like, how is something going to get better? I'm going to change all these to make sure this variable or this group of variables gets better. And both what you're telling it to optimize for, as well as what you're putting into that system, what variables you're allowing it to vary. And in the cases where you're training a model, what data you're giving it, which is, you know, kind of, you got to process and kind of understand what data you're putting in to make sure, you know, there's the integrity in that data to have confidence in the in the final kind of conclusion that the model provides. So, it's a fascinating time. I think there's a lot of neat methods coming out and a lot of creative ways to implement, some of the, more advanced kind of machine learning and deep learning methods. It's a super active area of research at, the academic level. And I think like Sportsbox AI, right, and Fenris and these companies.
Yeah,
right
those
now,
guys are really good stuff.
It's interesting to see how they're leveraging that technology to take some measurements from 2D video. Time will tell whether that provides the value to the, to the market, to the general golfer, to the coaches, that leads to longevity and innovation that lasts, right? But
do you see that it has it helped on reducing the amount of time, and that you don't have to do so much testing, and that you can put the info, especially since you guys have so many scientists involved, that you have a lot of data that is let's call it clean. If we can relate it, have an analogy like clean eating. If someone's going to eat certified organic, then they go to the doctor, they're obviously going to be, or they hope they're going to be healthier than if they're just eating whatever that they grab first from the grocery store, and that person's going to be healthier than someone's who's eating fast food all the time. But that you guys you're controlling your input to a greater extent than probably most. So you know that the data you're putting in is very good. So has that the AI giving you guys the ability to shorten the lifespan or the lifespan of a product from idea to production to out in the consumer's hands, to where maybe years ago it would have took, I don't know, I'm just throwing 3-4 years, and now you got it down to 18 to 24 months?
I would say it's shortened the, I have a hard time linking that to the development process, and it's shortening our development process. I think it's definitely shortened our kind of lead time to getting answers to questions. So like kind of on the R&D side, we're able to maybe find answers to questions much quicker than we would have been, maybe when I started, where we would have maybe taken the time to design a physical part and, all this stuff to test something out. Whereas now we have the capability through some AI tools, deep learning tools, to find that answer with the data we already have, rather than having to create new data, if that makes sense.
Yeah, absolutely.
So I'd say that's where it's starting to kind of produce some fruit in terms of time. And just allowing us to, I think Paul and I were the closest thing you had to a data scientist at Ping when I started. And we're by no means data scientists in the kind of true sense of the word. And now we have a number of them. And they're hugely valuable to our team.
What would be a roadblock with AI? If there's obviously a lot of positives, but are there any things that could be improved from that end of the business? And I'm sure it's obviously as it advances as fast as it does, but is there any roadblocks that you can see?
Yeah, I think it's just, it's making sure that you're confident in the output. And so, the roadblock or the challenge might be assigning more confidence to a result or an insight than should be assigned to it, because ultimately the proof is going to be, in the testing and how a human responds. And I think anytime you're, and maybe there's going to be methods to kind of explore this later on from an AI standpoint, but, it's really easy a lot of times if we're designing a club for a robot or something that's not a human, to turn AI loose and go wild. But humans are messy. I joke around a lot that I'm an introvert. I like dealing with models. I don't like dealing with humans. They're messy. But I think an area, and that's where I think Apple, you talk about Apple being innovative. They understood human behavior and human factor engineering in a way that allowed them to be incredibly innovative. And I think that's an area, and I know, my boss, Paul, and is super fascinated with it, Marty, and a lot of guys around here of how do we better understand the human experience, how they respond? And we've had a lot of conversation with Sasha about this, but get them to feel performance. What does performance feel like? And a lot of times, if you can produce that feeling of performance, it will lead to human performance gains. If nothing else, of that feeling of like, and that's why sound's important. That's why these different elements of, that reaction that somebody has can allow them to exert themselves and generate more club speed or perform in a way. And that's the limitation right now, I think, of things like AI and is that, and there might be someone a lot smarter out than me going, actually, no, we got human behavior down too.
I'm sure we'll get corrected.
From what I know.
I always get corrected by something on somebody on Twitter or Instagram. No, it's this. Okay. We only have so much time in a show.
I think that's an area that I think is truly human performance. And we just, John O'Shepard, really bright guy, Josh Turner, Chad, they started, and Paul kind of spearheaded this performance research center out in the UK at Loughborough University. So we have the team here, and then we have this team over at Loughborough that, it's our performance research center. So a lot of the questions they're asking are, okay, this connection between the club and the human, can we better understand that? And better, and that leads to fitting insights, that leads to product design insights. Can we better understand how that connection, how that, dead non-live club becomes a biomechanic kind of component in the player's hands, and how they respond to changes you make and things.
That's interesting you bring that up, because one of the guys I work for in club fitting, he was the first one that I had heard of talk about his system. He had a computer program that he would enter all your data, as we're talking about data input to get an output and get it as accurate as possible. So it did 30,000 calculations is what he told me, based off the input that you put in. But his whole theory was that, and what his genius was he was able to determine what type of power output the individual gave a club. And then he would match it. He could dial in the frequency of that shaft in addition to the profile to match their load value, the output, and everything. And I thought he was out of his mind when I first met him. Like, this guy's crazy. And then when he starts telling people, after he measures their clubs, after he runs them through test hitting session, he says, well, you hit this club this way, this club this way, and this club this way. Has never seen him play on a golf course. I'm like, this is amazing. So that was the first time I'd heard of it. Yeah. And I got to experience it. It was very, very eye opening. When as you're speaking of human connection to the club and do they match one another? Yeah.
Well, we work with Sasha McKenzie a lot too. I know we've mentioned his name. He's been on the pod a couple times. He great, incredibly smart biomechanics expert. And, that we have a lot of conversations about how does somebody's kinetics, so the force they apply, change, with different centers of mass, different, for something as simple as like the hosel design on a putter.
Yes.
Right. Like, how does their actual kinetics
sensory
change?
Mechanism.
Right.
Yes.
And it's fascinating to see how people respond to what they feel. And there's this whole other area of dynamic touch where, as you kind of change the mass properties of an object, it's going to influence the way you use that object. If it feels really good for hammering, you're not going to try and point with it, right? If it feels really good for pointing, you're probably not going to try and hammer with it. So, you can start to there's this, just crazy feedback loop that you constantly have to, we're still, I don't know, we're in infancy in my mind.
Well, and to give,
that well.
Yeah, to give a listener example, is that if somebody putted with a blade putter for most of their, let's say through their youth, and then they go get fit, and someone says, no, you should be more of a toe hang, or they're going to change the putter head design. That person has developed a feel based off the weight distribution and design of the putter head that they're going to have a certain pattern to their swing. And then you're going to change the head and move the weight around, something they're not used to. They're not going to automatically adjust to that new one right away. And they're like, well, why don't I putt as well as I did before? It's not as much nowadays because there's so much advancement in technology and people having an understanding of it. But the prototypical one was Payne Stewart when he switched golf clubs, when he was playing really well. And I think he went, and this is not a knock on Spalding, so hopefully nobody takes that way. When he went, I think, from Wilson to Spalding, and he had a hell of a time for that first year. And then I think they tweaked it, or they got him right, or they changed some things. I think Tom Washon had did some work for him and his clubs, and they finally got it dialed in. But it's not just an automatic, well, this guy's a great golfer, this girl's a great golfer, they can switch clubs and they're automatically going to produce the same results. It's like you don't know what you're doing, and you guys obviously do. Doing something like that can really, really mess up a golfer, that especially when they're as fine-tuned as some of these players are.
Yeah. Well, it's highlighting a lot of the challenges of, the fitting environment and trying to eke out as much performance as possible, and, trying to understand how that player is going to respond is a really hard thing to predict. It's something as simple as lie angle. You put, I remember we did a test with a bunch of tour players, and half the tour players, when you put a different lie angle in their hands would move up and down. And then the other half wouldn't do anything. And the toe would either be up or down, depending on the lie angle, and it's just something very simple like that. It's like there was a whole range of responses to how somebody responded to that. And a lot of times fitting somebody for lie angle with a putter, they just keep lowering their hands because they're used to seeing the toe up or toe down.
It's hard,
or whatever.
Hard to change a pattern when somebody's got it ingrained. Very hard. With one thing I want to ask you about all the data collection. If you take AI as a piece, and you take you guys are doing your own, and you take something like Arcos and Lou Stagner, and he's got 700 million plus swings measured and shots measured. And you had alluded to it that before, years ago, you guys used to have to use the ping man to test things, and then as companies went into bringing on tour pros, the men and the women, that they had obviously experts at ball striking, and then it has segued down into you bring in average Joes, I'm sure, periodically to test the things like that. But with those things like Arcos and all these other data capture systems, is that starting to influence the way that you design different clubs for the average everyday golfer?
Yeah, it already has. So a big piece of the G430 irons and how we went about the loft progression with those irons came out of analysis we did using Arcos data. So we have a partnership with Arcos, Sal and Tom there, and a number of others where, we ship in our clubs with sensors. We have a database of, like Lou, just a bunch of on-course data of people using our clubs, and we can then go in and go, okay, give us everybody using a G iron. What does their performance look like? What does their typical gapping look like? Break it into groups. So what we did when we looked at the G iron performance is we looked at, okay, guys who hit their driver 180 yards. And then we had another group that guys hit their driver 280 yards. And where they're hitting most of their shots. What's crazy is, regardless of how far people hit their driver, you get this kind of curve where close to the green, there's a huge frequency of number of shots. And then between like 30 yards and 100 yards, there's this valley where you don't get a lot of shots. And then there's this other bump between basically 100 yards and 180 yards, where regardless of whether you hit your driver 180 yards or 280 yards, you're hitting the majority of your shots, your approach shots, between 100 and 180 yards. And then you have, another bump around 350 to 400 yards, which is tee shots on par fours, right? And so we're like, man, for the G iron, here's our typical consumer. They're hitting the majority of their shots between 100 and 180 yards. Here's their current gapping with older G models. How do we then update our loft progression to ensure that people are best serviced where they're hitting the majority of their shots? And so it's really fun. One of our data scientists in our testing group kind of put together this report. We said, here's the question. He went in, mined the data, came out with some results, and that's what helped guide, the set makeup of the G430 irons. And I think Arcos is one of the next areas where I would love to get better data, because we get incredible data now in the lab, right? We have a motion capture system, we have a tee, we have launch monitors, we do so much testing here, Pete. It's like, So much data.
I mean, it says the putting lab behind you, so yeah, you guys got labs for everything.
I mean, I did a player test myself this morning when I got in. So, but what we don't have is a lot of data on course, right? What are people doing on course? And that's ultimately, there are certain behaviors, talk about human behaviors and just the context of performing around the green or on course is just, we don't have a lot of data. We try to emulate on course performance, and by having people rotate between an iron and a driver, and like around a golf, and then just look at the data. But we just a lot of times a lot like lightweight drivers, right? You have somebody just hitting balls on a range, and all of a sudden it looks really good, but then you try and match that with the rest of somebody's set out on the course, like. That's where it gets to be a challenge, right?
Yeah.
Something else that we pulled out of Arcos data that's influenced in design is just realizing, fatigue. So we did another looking at Arcos data, looking at players and looking at, kind of different demographics and how far they hit their first tee shot versus how far they hit their last tee shot. And you could see for a certain demographic that this, for the better players, for like the lower handicappers and typical younger golfers, like, they're peaking toward the end of their round, right? Their adrenaline's going, everything else, but there's a whole other category of golfer. By the time they get to 18, they're knackered, right? And so the driving distance drops. And that's where a lightweight set, right? Just taking into account fatigue can actually be a beneficial option for a lot of players to help mitigate fatigue and help people enjoy the game more. And it was interesting to see that pop out in the Arcos data.
Yeah, and the advancement, as we touched on a little bit earlier, that as different segments of technology catch up to other segments, I would have to say that the advancement in graphite as a material, so where it has become equivalent to steel in many aspects. The argument used to always be, and you never saw tour guys playing graphite, not in their irons, because as I learned, the loading properties of graphite, you could make a half a swing or a 3/4 swing, particularly with a wedge or low iron, and the head, the material steel would follow you. It was rigid enough and it was good enough. Graphite wouldn't. It took longer to load. So full swings, it was great. Half and 3/4 swings, it was not. But the technological advancements for the material has come along so far that they've caught up. And I know I turned 50 last fall, so I went to graphite and I couldn't believe it. Outside of it being for being, let's say you go from 125 or 30 grams down to say 95 grams or 100. I mean, that's a lot, but the difference did not feel significant. But it allowed, after 18 holes, I'm not sitting there saying, "Man, I need a nap." Yeah. To your point of being able to swing at the end of a round.
Well, and there's a lot of guys that, I've had a number of guys who are, either on tour or aspiring tour that are asking about graphite now. They've maybe lost a little bit of speed and they're looking for graphite options in their irons just because they can, graphite, it's light and it's strong. And so they're, LA Golf's got some good offerings and MMT, the MMT shafts with Mitsubishi are good options. And it's had a lot about our director of shaft development, John Oldenburg. He's been in the industry for forever, with Aldila and then LA Golf for a little bit. And he's now, designing our shafts, and talk a lot about iron shafts and, what could be done there. And the other cool thing about graphite, right, is it's super customizable. And so you can alter those layups in a way that you just, you got wall thickness and a step pattern of steel, and that's about it. Whereas carbon fiber, you got all sorts of different options to play with to really tune performance. And you're starting to see them. Sergio's playing, some graphite shafts right now and some blueprint irons, and you got Abraham Answer's playing some graphite shafts. I think the MMTs, and there's a number of them out there on tour now.
Yeah, Bryson was one of the first ones, the high public guys, to play it, and he's swinging as fast as he's swinging, and it's holding for him. So it's obviously working at those high levels. Before we jump to emergency 9, because I don't want to keep you too long, I did have one question someone submitted. Said when adding loft on a driver setting as adjustable heads, how does he want to know why it closed the face?
Mm-hmm. Yeah, that's a good question. So most adjustable hosel adjustability sleeves that help you adjust loft do so by tilting the angle at which the shaft enters the head. And so if you can imagine tilting that shaft toward the toe or toward the heel, that's going to affect your lie angle.
Mm-hmm.
And then if you go 90 degrees from that and you tilt that shaft, toward the face or back, that's going to affect your loft. And if the lie angle of your driver was 90 degrees, right? So if you took your score lines, went there and then went up 90 degrees and your shaft just went in like that, tilting that shaft would only affect loft. And then if it was, if the shaft was aligned with your score lines on a driver, it would only affect face angle. And so the fact that since the lie angle of a driver is not 0, it's not 90, whatever it is, 58 degrees. There's a component when you tilt that shaft that increases or decreases loft, but then there's another component that'll open and close the face. Now, in practice, right? So the reason it opens and closes the face is it's that 0-90 analogy. If you're at 0, it's only face. If you're at 90, it's only loft. Because we have a lie angle, it's not either of those. It's a little bit of both. But what happens in practice is people, very rarely do you have a ribbed grip on an adjustable driver, right?
Mm-hmm.
So what ends up happening is people end up, re-gripping a little bit in such a way that they're opening the face kind of about the shaft. So if it closes it a little bit, what they end up doing is kind of opening it a little bit, which adds a little bit of loft as they do that, or vice versa. But it's a function of the geometry that causes the face angle to change a little bit when you change loft, because that shaft isn't entering the head when you tilt it right at 90 degrees or at 0 degrees, where it would only affect loft or face angle. Does that kind of make sense?
Yeah, that's very interesting. When that got put out there, I think on Instagram, the fellow threw it out there, and as I was thinking about it, like that is a very good question, because I'd actually like to know the answer from a person who's designed clubs myself and know the details of that. Well, one last question on drivers is everybody went longer for so long, and now you see the tour pros, and the average driver out there, I think, is still 44 and a half. You would know better than I do. You work with a number of them. Average Joes are looking at 46, and they're saying, well, I swing this, and I get it longer on the one I hit in the center of the face, but I'm actually shorter. Should average players be playing a shorter than 45-inch driver, or is your average 18 handicapper better off trying to get that 46?
It's a great question, and I think there's going to be players that do better with each, right? And that's where I think a good fitter will explore those options and determine how a player responds to a shorter shaft or a longer shaft. Obviously, the benefit of going longer is speed.
Mm-hmm. Just through leverage and physics.
Right. And the advantage of going shorter is potentially more centered contact. And the other thing that varies when you go longer or shorter is you typically have to vary your head weight, right? So if I go longer, I typically need to use a lighter head. And if I go shorter, I need to use, I'll probably end up leveraging a heavier head. Mm-hmm. And with that comes a change in moment of inertia. So if I make something longer, I might be able to swing it faster, but the MOI might drop a little bit because I'm making the head lighter. Anytime you add mass or take mass away, you're influencing the forgiveness. And I think on average, the reason you see tour players going shorter and seeing better performance out of a shorter driver is that, one, they have plenty of speed. And so they go shorter and their heads are a little heavier, a little more forgiving. And at those speeds that they're swinging at, MOI is actually way more beneficial for them than it is for my dad, who's swinging at 85. Because the amount of ball speed they lose on an off-center hit because of the speed at which they're delivering that head, they get way more out of a more forgiving head than my dad would. Whereas my dad, he mishits it around the face a bit, but at his speeds, if I could get him another mile an hour of club head speed, even though he's playing a little bit of a lighter head, if he can make decent contact with it, he's going to see gains out of that longer shaft. And you in the intermediate, right? Look at LPGA length. It's not down at 44 and a half. It's at 45 and a quarter. Right. And obviously they're good, you know. I mean, shoot, I saw some stat of some of our ladies tour players. I think we had 3 of the top 5 in like fairways hit, and it was like, I don't know, some 95% of fairways or something was the number. And I'm like, good night. But you know, I think the reason LPGA you see them a little longer than PGA is just, you know, they at their speeds they're going to gain. The trade-off is they're going to get a little more out of the extra club head speed they get with the length than they would going shorter, having more control and maybe a heavier club head on a shorter shaft.
It makes sense. So it's player determined. So if you've got speed in the tank that where you don't, you know, Lou would kill me for saying this, but if you're going to sacrifice a few yards of distance, but you're at the PGA Tour level, but you're going to hit exponentially a little more fairway, which for them is control. That's somewhat of a fair trade-off. But the ladies who aren't hitting it as far, they're going to benefit from the extra distance because at their speeds are hitting the center of the face maybe more often. Yeah,
well, and I mean another way to with the speed to spare. I mean, it's, you know, you had Fawcett on your show at some point, Scott.
Yes. Mm-hmm.
You know, he advocates hitting a shape with your driver, and that shape shouldn't be straight. If I understand our conversations well, but by hitting a shape, you're losing distance. Like a curved ball goes shorter than a straight ball, and so the question is, you know, I mean, a lot of those guys hitting fades, you know, they're sacrificing a little distance, but
I think he and Michael Finney had the discussion.
Oh yeah, they had the discussion. We've had the discussion. It's, I mean, you know, and it gets into how is a player going to respond and all that neat stuff. And you could chat to Marty about it too. He's a better player than I am, and so he says he's embraced the single cross. You know, just let it fall left or right, and it'll be okay. But you know, there is that, you know, whether it's length or shot shape. You know, sometimes these guys are making a trade off of like, well, I'm okay with a little less distance with a little more control and predictability.
Mm-hmm. Yeah. Confidence at that level. It's all in how they're thinking. Cool. You got a few minutes just to do emergency 9.
Yeah.
These are just 9 random questions that are kind of fun to wrap up with. The first and the last one everybody has gotten since day one. So you and Paul can compare when this is released on those two, and then everything. You know, I've changed and modified and added and taken away some of the ones in the middle. So you're walking up to the first tee, whether it's the Ryder Cup or the President's Cup, your member guests, whatever tournament you're at, and they're going to crank some music for you. What's the song you're having them play?
Enter Sandman, Metallica.
Very cool. That was huge when I was in college. That'd probably be one of my list of 3.
Yeah, I don't know. I'd probably come up with another one, but that was the first one that popped into my head. So
hey, that's what the emergency 9's about. Anything that comes up quick. Here's one. This is a new one. Do you think Tiger is going to win again?
Man, I think I got this question somewhere, like, and it was pre-2019, and I said no. And then it's like, you know, oh, crap. Man, it's just, I'd love to see him win again. Mm-hmm. I don't, his mix of intensity and passion and like nothing beats him in contention in a major in terms of just, you know, the passion for the game. And I'd love to see him win again. And I'd talk to his doctor. I'll answer that question and say I'd love to see him win again. But, you know, he did not look like he was having fun in April or earlier this month.
No, and he just had that knee surgery, I think, to get rid of the arthritis.
So, but again, he had the whole, whatever they did, fusing some pieces of his back, and then he goes off and wins at Augusta.
Wins at Augusta.
You know, so maybe. I mean, if the body is willing.
Yeah, exactly. Now, no one has got to your level without doing a lot of reading. So very curious to hear what either what book is on your nightstand or what was the last book that you read?
What? So the last book I read was actually more of a fun read. I read Hail Mary by Andy Weir. He wrote sci-fi writer. So that was a fun book. And then yeah, the book I have on my nightstand right now is I think it's the Handbook of Golf Science. Sasha was an editor on it. Like, total geek for saying it's on my nightstand. But I was reading. There's a couple papers in there on skill acquisition that I was reading, that I have been reading, like Gabby Wolf and a couple others. The International Handbook of Golf Science or something like that. But it's a culmination of a bunch of different articles. I think Scoutlin's got an article in there. Sasha's got an article in there.
I got to get that. What's the name of it?
It's the International Handbook of, I think, Golf Science, and Martin Toms, I think, was the editor. Yeah, I could shoot
I'll
you
check
a note.
that out.
But,
yeah, I'll check that.
Yeah, it's got a bunch of really good papers. I think Sasha's got one in there on kind of science of shafts. But that's the one currently on my nightstand. It's a good book to put you to sleep when you're trying to go to sleep.
I'll let Sasha know that he said whatever, his article's good. Yeah. Better than melatonin.
Mm-hmm, mm-hmm.
Do you, of the two, do you love to win more or hate to lose?
There's definitely people I hate to lose to more than winning. I can tell you, just from playing and going out with buddies, there's definitely people I do not like losing to. But I think in the grand scope of life, I don't think losing bothers me as much, because I see it as an opportunity, and it makes winning feel that much better. I don't know if that fully answers your question, but
yeah, that's a very good answer.
I think the losses are the things that typically lead to the wins. And so I think the wins feel the best, but the losses, I think I enjoy as much in retrospect, because they're typically the things that lead to the wins. I feel like I'm hopping out.
Well, no, it goes along with what you mentioned.
But...
Yeah, it goes along with what you mentioned about Giannis earlier. What his response was to that reporter.
Yeah.
Your favorite purchase under $1,000, let's say in the last couple of years. All the scientific talk, that was easy. So I got to give you something to make you think a little bit.
My favorite purchase under $1,000.
Mm-hmm. I mean, it could be something as simple as a pair of sandals, or it could be a watch that that was pretty expensive. Whatever, anything in between.
Yeah, it was the foosball table I bought my kids for Christmas, I think. I think it's worn off its luster recently, but I would say, just thinking in the near future, or in the recent past, that just having that in the backyard and being able to, kids had a great time, and I'd say that's probably the most fun purchase that's recently.
Perfect example of the type of answer I'm very interested to hear people give. A couple more.
What I got.
They're going to make a movie about your life. Hollywood calls you. Who's going to play you?
Christian Bale.
Good. Yeah, that's a good one. That dude's awesome.
Oh, he's incredible.
The range that he has, where he played that super, super skinny guy. What did he lose, like 100 and some pounds? And then he goes and he plays in that movie with.
He was in The Machinist, and then he went.
The Machinist.
Batman. Then it was.
Then he was that overweight, heavy guy with Jennifer Lawrence, where he had the comb over. He was the con man.
Ford versus Ferrari was incredible.
Yes.
I don't know. I'd say Hugh Jackman, because I really like Hugh Jackman too. But I don't think my physique lines up as much with Hugh Jackman as it does Christian Bale.
We're not going to be calling it Wolverine anytime soon.
No, don't think so.
If you could caddy for anybody in the world, who would it be?
Arnold Palmer. Can it be alive? Or does it have to be alive? Or
it can be anybody throughout history of the world if you wanted it to.
Yeah. Arnold Palmer was the first one that came to mind. I think that'd be incredible.
Two more. Would you rather play your worst round ever and have a hole-in-one, or play the best round of your life?
Best round of my life. Oh, yeah, easy.
Yeah, it wouldn't cost you as much either.
Yeah, and then maybe that's, I guess, yeah. I mean, I've had 2 holes in one, and then like best round of my life, and I'm like, best round of my life so far is like, that was way better than.
Yeah, that feels good for days, if not a week or so. That you.
Oh, it still feels good. It's like you're like, oh man, I can do it. Like it's in me. The hole one's just, you have plenty of good shots. Sometimes they go and sometimes they don't. But man, you have that round and you're like, wow, I know I have really good scores in me. It's just a matter of, practicing and
putting it together.
Opportunity meets preparation. So,
and then last one, in your opinion, greatest golfer of all time.
Greatest golfer of all time. I mean, it goes into the just Tiger thing. I think for me, and growing up watching Tiger and not, saw a little bit of Jack toward the end, but it's hard to not say Tiger. Just absolute. I mean, as a player, just incredible. It's been, I grew up playing tennis, and it's interesting just with golf. I don't know if there's been in tennis, right? Just had this season of 3 of the best to ever play the game all playing against each other. So that's a much harder question versus with like Tiger versus Jack and all that stuff. It's, 2 different generations. It's really hard to kind of, compare, and you're like, both pretty good. But I mean, for me, it's, if I had my choice to watch Tiger or anybody else in the major on a Sunday in contention, it'd be Tiger because of just all that he's done and what, the history and what he's brought to the game. So
the answer that's been largely generational, depending on age, 50 plus has been heavily towards Jack, under 50 has been heavily towards Tiger, but Tiger as a whole has taken the lead by, I would say, about 20%. As 4 years now I've been doing this, Tiger's taken the lead. So it obviously there's no wrong answer. I'm just curious to hear what people think.
And honestly, I might have answered differently before 2019. I mean, that was just so incredible. I mean, it was just like, how do you not? But anyway.
Yeah, it was very, very cool. I know you do a lot of speaking. Obviously, you've done Coach Camp a number of times. You got anything coming up where you're talking either at a section sponsored event or anybody else or anything that you're doing?
Right now I don't have much on my calendar. Got some potential trips that don't involve speaking that are work related trips, but nothing super educational. The fall there's usually a lot of those opportunities and seminars and between open forum and Coach Camp and things like that. So right now nothing on the calendar, but I'm sure something will pop up here in the near future.
Someone will be reaching out to you soon. And best, I'll have all your social media handles. Best to have yours, or you want Ping's in there, whatever you want.
Yeah, I mean, I think definitely put Ping in there, and if you could tag both, that'd probably be best.
Not a problem.
Speaking on behalf of the company as much as myself. So that'd be great.
Not a problem. Erik, has been great. I really enjoy. I could talk to you and Paul about pick your brains about all the research and everything behind clubs forever. And then I hope guys don't mind if I bug you with emails and messages from time to time with other questions.
I'd love it. Yeah. So appreciate you asking me to be on, and hope your listeners enjoy.
Awesome. Hey, hang on just a second as this uploads, and let me shut this down. Take care,
Sounds
everybody.
good.